Today we talk about how to extract the S parameter of a package. So we know like how to extract the S parameter in PCB. It is a similar process, but some new option and some new parameters are there which we come to know like how to extract the S parameter of a package. Let's start by step how to do that. So what are the terms involved to do the S parameter extraction of a package? So the things are involved in the extraction of S parameter is like basic setup. First fill the stack up, and for stack up we have to get the material property from the vendor. Then there is an option to assign a personal library if some new item or material property we need to add, then we have to assign a personal library in a stack up. Then we have to give via property. Via property is like copper material property, same property we have to provide to via. And then we have to assign the property of dia and ball, BGA ball side. So it's a depend upon what type of dia side and solder ball side. Like dia side is spherical or cylindrical, and BGA side is cylindrical or no mm, uh, cylindrical or sprite shape. Then we have to go to tool setup, basic points and parameters. So first we get that package layout file into the tgz file or odb++, both are same. Import this file into the tool file. uh, Maybe tool is any like ANSYS or Cadence, any tool where we import that file. Then we have to change the unit to depend upon that layout is done in micrometer or nanometer. So we have to select that unit. Then update the stack up with proper material property, as I said before in previous slide. If there is any specific material, then add that library as a personal library. Then how to do the tool setup, 3D extraction more. For 3D extraction we need more memory space and RAM, some specified RAM that is dedicated for the simulation. So we have to see like how much memory is required and how much core of RAM is required, that we have to set up before the simulation. Then step first is select the net including with VSS or ground. Suppose you are going to extract as parameter of a DDR byte, then that particular byte like 0 to 7, if 8 bit, then with that DDR signal we have to take that VSS or ground signal. Then make a cutout by selecting net either automatically or manually. So for to uh, to minimize the time of simulation we have to cut that particular section. Okay, then delete extra via and ground are necessary to simulation. Yes, so extra wires and ground we can reduce to that cutout section. Create model as per next. How to create the model we'll see. So we'll view these properties like uh, part name, part type, reference texture, number of pins. Then we'll get this model interface. So here we are talking about the die parameter. Die parameter means that die side, how to select to create the model. Interface, we have to select manual, die property, flip chip, orientation of that flip chip is chip down, height we can keep 0, shape we can based on our designer we have to select cylindrical, or mostly a die side should be cylindrical. Diameter depend upon our design ball size, die size, that is, suppose for example I have taken 70 micrometer, mid diameter that is blank for the cylindrical, and height is 67 or whatever, that should be less than our diameter, and material we can keep solder. This is the model assignment at the uh, die side. BJ ball side, same, will see the option like manually, go through the manual. Shape should be spheroid, and example, diameter is 346, mid diameter is 462, and height is 303. Material solder, uh, or so these are the BGA ball diameter parameter. We'll go to the next slide. So after assigning this model, we'll see spheroid or cylindrical model connected with the die, uh, and yeah, even after model we can create the ports. So ports look like, so one side we are uh, we see this model BGA side and BJ ball map model. Step 2, create ports only for selected net. So and exclude the VSS. So port is only generated at the signal nets, not on ground. Once port generates, check in the ports or excitation option whether all ports are there or not. We have the two, always check that all signal is selected and ports are generated or not. Reorder the port by selecting excitation. We can arrange or manage the excitation ports. After setting up all, save the file. Okay, we have to save actually file all the time. If any changes we make, then we have to save the file. Check geometry, we have to check the geometry where our geometry, whatever model we are created, that geometry is correct or not. After successfully geometry check, run the validation. So the second option is validation, where validation will say like your all the setup is correct or not. If any error is there, then we have to correct that, and then we again go for the geometry and run the validation until unless all the error will 0. So this one is the step 2. Next point, need to remember before running the simulation, need to assign via material property, going through edit pat stack and search the via, assign one by one via material. So how many vias are there for all via, we have to assign via property with the material, and these are the options you will see in your tool. You have to assign that property. Before run the simulation, we must give setup in analyze option. Yeah, we have to give setup like what will be the frequency and frequency range and what type of simulation will under analyze or run. We need to set up one setup option, and option 2 is sweep. Setup required, these are the option: frequency, maximum number of passes, maximum delta accuracy, that card solution frequency. It can be single, multi frequency, you can do logarithm. It's come under adaptive solution simulation. Other point like refinement, lambda